if you're not a huge fan of human beings, but you really like puzzles, and you're good at math, physics is very attractive because it's the greatest puzzle there is in our universe, and it exists completely independent of humanity. And yet humans have been able to work on it and make progress, which is freaking amazing.
I want to say also why I think I'm so focused on theoretical physics as the most important endeavor that humans are engaged with. And I think there are three components to it, and just see whether it resonates with you. One is that this is the closest we get responsibly to asking, why are we here? What is it that we're made of? It is the thing that would best substitute for a religion if you were able to understand what it was. The second thing is that it appears to be the secret powering our economy that very few people have really fully understood. It gave us the World Wide Web, the semiconductor, the electron shells that generated chemistry,
nuclear power,
nuclear weapons, communications technology, electromagnetic, Wi-Fi, what have you. If you wanted, and it invented the theoretical physics, more or less created molecular biology.
That's probably a bit of a stretch, but the others certainly aren't. So, yeah. If
you look at the RNA tie club, the people in it were Teller, Feynman, Crick, people trained in physics. So in this telling of the tale, its second major feature of importance is that it sort of created our modern economy. And I don't think people have understood the extent to which all of these things, from the web, semiconductors, and even molecular biology, really came out of theoretical physics because of the third issue, which is, I think, even though I'm a mathematician or trained in mathematics, I could make a pretty decent argument that this was the world's most impressive intellectual community ever.
It seems to attract some of the greatest minds.
Well, I would go even farther. I would say that because of the interplay between the most beautiful mathematics, even according to mathematical standards, and experimental discipline. So you have this thing that's forcing you to go back and forth between the purest of pure theory and the dirt and intuition and messiness of experiment. I don't think anything else had that property. So that it wasn't necessarily even that it just attracted the best people, but it actually rewarded human intellectual achievement like no other subject ever.
Right. It's also touching on something that's a little bit different socially, which is the type of people who are attracted to really hard problems in fundamental physics and modeling, and really trying to get, as you say, the source code of the universe. These often aren't very skilled people. They're not very socially oriented people for the most part.
Some are, some aren't.
Yeah. But for the real intellectual heavy hitters, you're talking about people who sort of, walk among us as aliens. You're talking about that they're not extremely social. They're not very focused on issues with other human beings. And physics, this understanding of our universe through mathematics, is really an otherworldly pursuit, right? It's not like law, where laws are made up by humans and discussed in front of humans and combated in front of humans. That has its own intricacies and difficulties and puzzles. But theoretical physics, you're working at something that's not related to humans directly. Any intelligent beings in this universe that advance to a certain state are going to be involved in studying physics. And it's going to be the same physics, right? With some of the same mathematics and the same mathematical tools. It's something that exists independent of humanity. So if you're not a huge fan of human beings, but you really like puzzles and you're good at math, physics is very attractive because it's the greatest puzzle there is in our universe, and it exists completely independent of humanity. And yet humans have been able to work on it and make progress, which is freaking amazing. It's amazing the degree to which humans have understood our reality. And I think we're getting close to having
I would say
complete
it's one
picture
of the
it.
three classes of greatest puzzles. I mean, if I could tell a story that biology is the greatest puzzle because without something to care about the universe in which it lives, this is all completely sterile to begin with. And I can also make a different case for mathematics, which is that physics is but one example of a universe. We don't know if there are other universes that could be constructed.
So biology, I mean, I agree, it's intricate and it can be a pure pursuit, but it's not pure in the sense that so much of the foundations of biology are somewhat arbitrary. Like whether a DNA helix is going to spiral to the left or the right, and what its chemical components are precisely, that might vary. Other planets, other civilizations, biology is going to be different.
You could make a decent argument that systems of selective pressures, as described by Darwin and Wallace, might be conserved even if you didn't have carbon-based life.
There will be convergent evolution, of course.
Sure.
But the details will be slightly different. So if you're studying biology, by the time you get up to something like cells or animals, it's going to be wildly different in different places in the galaxy, all right? Whereas physics is the same everywhere. Okay, it's independent of biology, and it's independent of humanity. And it's I think, and then when you go to mathematics, the pursuit of mathematics, like how things get proved, and how structures get built up through axioms that are then proved, it's a larger playing field than physics. So within that huge arena of possible mathematical structures, okay, we appear to live in one mathematical structure. So, I mean, a physicist only has to focus on the mathematics that describes reality.
And by the way, I share your intuition that in a certain sense, this is the best and most interesting place to play, in part because there's this very weird feature that we've seemingly unearthed about the physical universe, which is that it unexpectedly has this bizarrely good taste about what to care about within. It's as if you let it loose in the mathematical jewelry store, and it selects only the finest pieces.
Yeah, and we have to wonder if that's, is that just our human take on it? Because our human aesthetics have evolved within this beautiful world and universe. So is it that, Douglas Adams described the anthropic principle as a puddle of water, right? Thinking it's like, wow, this hole I'm in is just perfectly formed to my shape, right? Isn't it wonderful how it just fits me so perfectly and it's so comfortable here, just like it was made for me? Well, it's like, no, the puddle got there and filled the shape of the hole. I mean, the water got there and filled that shape. And as humans, we ended up here and we filled this niche, and our aesthetic taste was shaped by what's around us, including the mathematics that underlies the physics of this universe. And so when we look at the universe, you might say, oh no, maybe it's just our tastes evolved within this universe. So this is why we find physics aesthetically pleasing.
Do you actually believe what you're saying right now?
No, I think it's wrong.
I mean, I think this is so cowardly.
I know, I agree, and I have to wonder about it. I have to. I mean,
I understand we have to pay lip service.
No, it's not just lip service. I think about this. I mean, is it really my proclivities have been shaped by my environment in order to think this? Because I have to question everything all the time.
Sure.
Mostly because I don't talk to enough other people, but also it's because when you're questioning things and you're delving with fundamental building blocks, you want to make sure as you build things up that you have things right. And in looking at the fundamental pieces of physics, the fundamental mathematical physics, I really think that the mathematical pieces, as you say, are the ones that are extraordinarily beautiful. And it's not just my aesthetic taste that's been shaped by evolution that causes me to think that. I really think objectively, these are very pretty mathematical objects underlying our physical reality.
Yeah, I think we just lack the courage to say what this appears to be, which is there is something that we do not understand about the universe in which it is selected for the most mysterious, most beautiful stuff with which to write the closest thing we have to source code. We're not at the source code yet. We're not quite at that layer.
Right. But you can smell it, can't you?
Well, I mean, yes and no.
It feels close.
I think it's almost provably close, but there's a caveat to that, which is I think we're almost at the end of this chapter. And it does feel like it could easily be the final chapter. And by the way, we should clarify that when we talk about a theory of everything, we don't mean a theory that once understood could explain everything you see in your daily universe.
Right. Love is still going to be a mystery, of course.
Oh God, you really did that?
Of course I did. But yeah, no. But
Ladies,
I mean,
form a single file line.
There's evidence. I mean, in our understanding of physics, as we've learned more particles, the fundamental particles we've learned about appear to be filling out a complete set. I mean, when you predict that a tau quark should exist, right, or no, that a tau lepton should exist, you figure out that it completes the set. It's this third generation. It's complete, right? So we seem to be completing our set of fundamental particles.
So we have 3 sets of Lego.
Yeah.
Right? The first generation, second generation, and third generation of matter. Yeah. And all the pieces in each generation are mirrored in the other 2 generations, just at different mass scales so far. That's what it looks like.
Well, it's not just so far. It's like we have reasons to know that there aren't more. I mean, from how the Big Bang set matter loose in the universe, we know that there aren't more than 3 generations up to a certain very high energy.
Well, we've known a lot of things, Garrett, that have turned out to be wrong.
Well, but this is really filling out a pretty complete pattern.
I don't dispute, but I just
except for this minor point of dark matter still being completely unknown for the most part.
Yeah, I mean, I guess my discomfort with this comes from the fact that knowing the history, I know how we've been wrong, and I also know how we haven't had the courage of our convictions. And one of the things that really, occupies my mind is why we're not more definite about things that I think we have very good reason to believe, and we're so definite about things that sort of scare me, where we say, I know that it can't be other than this, and yet it has. We've been shown up multiple times. We've got 2 different directives telling us to be both more confident and more humble.